Hi, this is lesson 5.2. We're going to be writing equations from tables. So let's get started. I'll share my screen with you. Okay, so our objectives today are I can graph from a table to write an equation, and I can write an equation from a table. Okay, so our standard is still F4. All of this should make sense to you. Construct a function to model a linear relationship. We haven't talked much about functions, but that's coming up. But we have talked a lot about linear relationships. And be able to model that between two quantities, determine the rate of change, that's our slope, and initial value, that's our y-intercept, of the function from a description of a relationship, that's a word problem, or from two xy values, 2 points, including reading those from a table. We've had tables, or from a graph, and we've had graphs. Interpret the rate of change and initial value, that means tell what it means, of a linear function in terms of the situation it models and in terms of its graph or a table of values. Okay, so let's minimize myself and we will continue. Okay, graphing from a table to write an equation. The table shows the temperature of a fish tank during an experiment. Table's down here. Graph the data and find the slope and y-intercept from the graph. Then write the equation for the graph in slope-intercept form. Remember back, one of the lessons was talking about the 3 different ways you can write linear equations. There was the point-slope form, the slope-intercept form, and then the standard form. So we're mainly working in the slope-intercept form. So this table here is showing us time in hours, and that black bar is at the bottom. That'll go away in a minute. And temperature in degrees Fahrenheit. So notice, first of all, that as the time increases, the temperature is decreasing. So that means that our slope is going to be negative, right? It's going to go downhill. So let's take a look at this. So first, our step is to graph the ordered pairs from the table, x being time and y being temperature. Our ordered pairs would be 085, 275, 465, 655, 845, and 1035. So let's graph those. So that's 085. Notice how that is also the y-intercept because it's on the y-axis. Our next point is 275. Then we have 465. And remember that the x value always comes first, and then we rise the number or we go down the number, depending on if it's positive or negative, for the y value. Then we have 55. And then we have 845. And finally, we have 1035. Step 2 then is to connect the dots. That is the fun part. Yay! So we connect the dots there. We make our linear graph. And now we do step 3. We're going to choose 2 points on the graph to find the slope using the slope formula. So any 2 points will work. I always try to pick the smaller numbers. You can pick any 2 that you want. So we're going to use the formula y2 minus y1 over x2 minus x1. You should be very familiar with this slope formula by now. So let's plug in 085 and 275. And you can look on the graph to get those, or you can look on the table to get those. So y is on top. So we're going to do 75 minus 85. Notice how I took y2 as my 75 point, because remember we said that this graph is going to be going downhill, and it is. So we're going to end up with a negative number for our slope. And then 2 minus 0 on the x values. Do the math, and you get negative 10 over 2, and then you divide that, and you get negative 5, because negative 10 divided by positive 2 is negative 5. So that is our slope. Slope is equal to negative 5. Now we have to do step 4. we're going to read the y-intercept on the graph. I already pointed out where that was. Do you see it? Yep, there's the y-intercept. That's the point that crosses the y-axis. And that's at 0, 85. Notice how on the y-intercept, x is always 0. So there it is, 0.085. Notice how 85 is the value by when time is 0. And then we have to plug in the slope and y-intercept into the equation. What's our equation? Well, in slope-intercept form, it's y equals mx plus b, where m is the slope and b is the y-intercept. Should be familiar with this by now as well, after all of these lessons on this aspect of the equation. So we're going to plug in what we need to do. So we need to plug in -5 for the slope, and we need to plug in 85 for the y-intercept. So our final answer for the equation is y equals -5x plus 85. So what does that mean? Well, at -5, that means the temperature decreases 5 degrees Fahrenheit every hour. That's the unit rate. That's the slope. What does the 85 mean? That's the temperature starting value. Remember, the y-intercept is the initial value. Initial means the beginning value. So that's what the temperature starts at, and then it starts to fall every hour. Okie dokie, let's try another one. This time we have volume and time. The table shows the volume of water released by Hoover Dam over a certain period of time. Notice how time is in seconds over here. Graph the data and find the slope and y-intercept from the graph. Then write the equation for the graph in slope-intercept form. So step 1, we're going to graph the ordered pairs from the table. Don't get confused because it's left to right now instead of up and down. Time is your x, that's your independent variable. Time never depends on something else. It's always the x, independent. And the volume of water depends on how much time has passed. Notice how that's a lot of water every second, isn't that? Look at that. For time, for 5 seconds, 75,000 meters cubed of water is going to pass over the Hoover Dam. So let's plot these points. So we have 5, 75,000. We have 10, 150,000. And sometimes you have to look at these intervals to say, well, what is this? Well, it's got 4 lines between, right? 100,000, 125, 150, 175, 200, 225, 250, right here's 225, 250, 275, and 300, etc. So it goes up by 25,000. Now let's plot 15 to 25. Oh, forgot to put the 10 in there. So 15 to 25 is right there. And 300,000 is right there. And then the fun part, connect the dots. So far, so good. Okay, step 3. Choose 2 points on the graph to find the slope using the slope formula. Well, our slope is there. I didn't mean for it to pop there ahead of time, but let's see how we get it. y2 minus y1 over x2 minus x1 is equal to, so I'm going to pick 2 points. You can either look at the table or the graph. So now I'm going to do my y points. So I'm going to go 150,000 minus 75,000. The 10 goes with the 150,000, as you notice here. And the 75 goes with the 5, as you notice here. Then you do the math, and you get 75,000 over 5. So divide that out, and that will give you your 15,000. So the slope is equal to 15,000 in this one. Now we have to read the y-intercept on the graph. Well, where is the y-intercept? Yes, it's at 0, 0. There it is. There is no y-intercept other than 0. So now we have to plug the slope and the y-intercept into the equation. Y equals mx plus b. M is your slope. B is your y-intercept. So there's your slope, 15,000, and there's your b, your y-intercept of 0. So because b is 0, we can just drop the b. So we end up with y equal 15,000x, no b. We could put plus 0, but it doesn't necessarily have to be there. So what does this mean? This means that 15,000 meters cubed of water goes over the Hoover Dam every 1 second. That is a lot of water. And what does the y-intercept of 0 mean? That just means that at no time, when the time is 0, no water has yet gone over the Hoover Dam. Okay, now you get to give this a try. Oh, the volume release started at 0. We just said that. Okay, so now you get to give this a try, and I'll see you back in a moment. Pause the video, do the questions, and come back. Okay, welcome back. Now we're going to talk about writing an equation from a table. Very similar to what we just did. Elizabeth's cell phone plan lets her choose how many minutes are included each month. The table shows the plan's monthly cost y for a given number of included minutes x. Write an equation in slope-intercept form to represent the situation. Notice how as she has more minutes that she's talking on the phone, the cost is going to go up. Just kind of keep that in mind. That would probably mean we're having a positive slope, right? Okay, decide if the table is linear. Now we don't have a graph to say, oh, that's a line. We have just a table, so we don't know if it's a line until we check to see that it's linear. We check by doing the change in y over the change in x. If it's the same for all the points, the table is linear. So let's do that check. So from 14 to 20, the change in y is equal to 6. From 20 to 26, the change in y is equal to 6. From 26 to 32, the change in y is equal to 6. And finally, from 32 to 38, the change in y is equal to 6. So far, it looks linear, but let's check the top. So from 100 to 200 is a change of 100. So the change in x is 100. The next time the change in x is another 100, from 200 to 300. And then we have a change of x equal to 100. And then the last one, the change in x is equal to 100 there. So yes, we have a linear equation because the change in y over the change in x is always the same. So step 2, we're going to choose 2 points. It says on the graph, but in our case, it's on the table, to find the slope using the slope formula. So we're going to pick those 2 points, 14 or 100 comma 14, 200 comma 20. So we use our formula y2 minus y1 over x2 minus x1. My y2 is going to be my 200. My x2 is going to be my 20 minus 14. That's wrong. No, it's not. That's right, because y is the cost. So 20 minus 14 is on the top. That's my y. See, it's easy to get mixed up. And then my bottom is the x's, 200 minus 100, and now I subtract. I do the math. I get 6 over 100, which is equal to, as a decimal, 0.06. Okay, we'll talk about what that means in a bit. So our slope is 0.06 right over here. And now we have to find the y-intercept. It's a little different now, using the slope and any point on the graph, and then we solve for b. What do I mean by that? Well, let's take a look. Normally, our equation is in the format y equals mx plus b. Well, we know the slope to be 0.06. We don't know the y-intercept. That's what we're looking for. So let's plug 0.06 in for m. That's our slope. And now we're going to plug in any point for x and for y. So I'm picking the point 100 comma 14. Don't pick 100 comma 20 because that's not a pair. Has to be a pair, right? Okay, so let's plug those in. So now my equation becomes 14 equals 0.06 times 100, that's the x value, plus b. There's where the 14 comes from, and there's where the 100 comes from. I just plugged in an x and a y value. And the 0.06 is the slope. So now we have everything we need to solve for b. So our first thing is to use the order of operations and multiply these two numbers. So let's do that. Solving for b means to get b all by its itty-bitty self on one side of the equation. So first we multiply. 0.06 times 100 turns out to be 6. We still have our 14 on the left side, and we still have our plus b over here. Now we have to get rid of the 6 from the right side so we can get little old b by itself. So in order to get rid of the 6, I need to do the opposite. It's currently a positive 6, so I'm going to subtract 6. And I need to do the same thing to both sides of the equals. Otherwise, it's no longer an equal equation. So I subtract 6 from the left side as well. And now on the left, I get 14 minus 6 here. And on the right, I get 6 minus 6. Well, what is 6 minus 6? I hope you said 0. So we can cross off the 6 minus 6 because 0 plus any number b is just b. And then on the left side, 14 minus 6 is 8. And we're left with b on the right side. So our y-intercept is equal to 8. Now I believe we have all the missing pieces. We can put it together now. Plug in your slope and your y-intercept. Y equals mx plus b. We've got our slope and we have our y-intercept. So we just put it in there. Y equals 0.06x plus 8. That means whatever point value or whatever number of minutes I put in for x, that's my input. If I calculate it out, I'll get an output of some cost. So now, there's your slope and there's your y-intercept, but what do they mean? Well, the phone costs 6 cents per 1 minute. That's your rate. And the y-intercept of 8, what does that mean? Right, that is the one-time service fee. Remember how it said there was a service fee up here? So there's your equation. Very helpful if you wanted to say, I wanted to talk for 500 minutes. How much is that going to cost me? Well, you just multiply 500 times 0.06 and add 8 more, and that'll tell you. So the equations are very useful. Okay, let's take a look at another one. A salesperson receives a weekly salary plus a commission. You guys all know what a commission is? That's an amount of money that you're paid for selling a certain number of things. So this salesperson, he's going to get a weekly amount, whether he sells anything or not, and then he's going to get a commission for how many computers he sells. So the table shows the total pay, P, and the number of computers sold, N. Write an equation in slope-intercept form to represent this situation. So step 1, decide if the table is linear. Don't forget that step by checking if the change in y over the change in x is the same for all points. So if we check 550 to 700, that's an increase of 150. So the change in y is 150. From 700 to 850, the change in y is 150. From 850 to 1,000, the y is 150. And from, that one's kind of off a little, but should be from 1,000 to 1,150, the change in y is 150. Now we check the x's. From 4 to 6 is 2, right? So the change in x is 2. From 6 to 8 is 2. The change in x is 2. From 8 to 10, the change in x is 2. And from 10 to 12, the change in x is 2. So we know this equation or this table is linear. Choose 2 points on the graph to find the slope using the slope formula. y2 minus y1 equals x2 or over x2 minus x1. So let's see what happens. We're going to pick these 2 points, 4, 550 and 6, 700. So we'll do our calculations with our y2 minus y1 over x2 minus x1. And we get 700 minus 550 and 6 minus 4. If I do the math for that, I end up with 150 divided by 2, which we cannot leave it that way. So we're going to call it 75. Okay. Find the y-intercept using the slope, the 75, and any point on the graph and solving for b. Well, if I were wanting to do this at home, I would do the easiest point. You might want to try a different point. That's up to you. So use the formula y equals mx plus b. Plug in your m, that's your slope, and your b is your y-intercept. So there's plugged in. Now 75 is the slope. Now we have to plug in an x value here and a y value here to get b. So let's see. We're going to pick the first point, 4, 550. So when we plug that in, the y value has now been replaced by 550. This is the slope, and this 4 is the value of number of computers at the top of the 550 over here on the table. And then we just multiply first. So 75 times 4. Oh, there's your y point, and there's your x point. So 75, and there's your slope, times 4 is 300 plus b, and on the other side, it's 550. So we're going to subtract 300 from both sides so that this gets rid of the 300 on this side, but adds it to this side. So we're going to end up with that crossing off, and we're going to get 250 equals b. So now we can plug in our formula. The y-intercept is 250. Plug in your slope and y-intercept. Y equals mx plus b. Our equation was y equals 75x plus 250. Here's your slope. There's your y-intercept. Commission received for every computer sold is the slope. Weekly salary, no matter how many computers are sold, are 170. I mean, weekly salary, no matter how many computers are sold, is 250. I was thinking of the 75. It's 250. The y-intercept. Okay, you get to try some of these type of problems. See you back in a minute. Okay, welcome back. Now let's focus on some higher order thinking. If you have a table that shows a linear relationship, when can you read the value for b? It should say, where can you read the value for b? In y equals mx plus b. Directly from the table without first drawing a graph or doing any calculations. I'm just going to fix this, y equals mx plus b, and this should say where. So if there is a point in your table with 0 for x, this is the same table we saw earlier, then the y value in that table is b, because at the y-intercept, x is always 0. So if you see a 0 here for x, then the corresponding y value will be your y-intercept. Okay, try a problem like this. I'll see you back in 1 minute or 2. Okay, welcome back. We are now going to be talking about our homework for Google Classroom. That's where you look. It's going to be lesson 5.2. And that concludes our lesson. Have a good day. Bye.